Hi friends, in this lecture we will continue problems on Green's theorem. Verify Green's theorem for integral xy plus y square dx plus x square dy over the closed curve C, where C is the closed curve of the region bounded by y equal to x square and y equal to x. So first of all, what is the statement of Green's theorem? So that is integral m dx plus n dy over the closed curve C equal to double integral of dou n by dou x minus dou m by dou y dx dy over the region R. In case of verification, we have to calculate this value and this value. If these two values are equal, then the theorem is verified. Now we have to compare the given problem with integral m dx plus n dy, m equal to xy plus y square and n equal to x square. Now first we will calculate this part. So that is double integral of dou n by dou x minus dou m by dou y dx dy over the region R. So for this we have to find out dou m by dou y and dou n by dou x. So dou m by dou y, we are differentiating this xy plus y square with respect to y partially. So with respect to y, so y is 1 into x, that is x plus y square derivative 2y. Now dou n by dou x, we are differentiating x partially with x square partially with respect to x. So x square derivative 2x. Now substitute these two values in this, that is dou n by dou x minus dou m by dou y. So that is 2x minus of x plus 2y. Simplify, open this bracket. 2x minus x, that is x minus 2y. So therefore double integral of dou n by dou x minus dou m by dou y dx dy over the region R equal to double integral of x minus 2y dx dy over the region R. Now you have to find the limits of x and y. So given region is y equal to x square and y equal to x. So y equal to x square is a parabola symmetrically about y axis, and y equal to x is a straight line passing through origin. So now find this. So since y equal to x and y equal to x square, now write down this. In place of this y, write x square. So x square equal to x. So move this. X square minus x equal to 0. Take x common. X into x minus 1 equal to 0. Therefore we will get x equal to 0 and x equal to 1. So therefore x limits are 0 to 1. If we are substituting x equal to 0 in this, since y equal to x, put x equal to 0. So therefore y is also 0. Again put x equal to 1. So if x equal to 1 means y is also 1. So therefore this curve y equal to x square parabola and this straight line are intersect at 0, 0 and 1, 1. Now what are the limits of x and y? Now x is varying from 0 to 1. So x limits are 0 to 1. Now y is, see this, it is moving along this and along this. That means along this curve y value y equal to x square and along this line y equal to x. So therefore y is varying from x square to x. Since y is dependent on x, we are integrating first with respect to y. So x into integral dy, that is y, minus 2 into integral of y square by 2. So cancel these 2. So substitute upper limit minus lower limit, x into y value x minus x square minus of, again put x y equal to x, that is x square minus x square whole square, that is x raised to 4. So simplify this, x into x square minus x cube, open this bracket, minus x square plus x raised to 4. Here we will get minus x square, this is plus x square. So these two get cancelled. So therefore x raised to 4 minus x cube. Now we are integrating this with respect to x. So integral of x raised to 4, that is x raised to 5 by 5 minus x cube integral, that is x raised to 4 by 4. Now substitute upper limit and lower limit. So 1 by 5 into 1 minus 0, that is 1 by 5 only, minus similarly for this 1 by 4. So take LCM is 20, 4 minus 5, that is minus 1 by 20. Now calculate this integral m dx plus n dy over the curve C. So how to calculate this value? So you have to calculate this single integral along this curve plus along this line. So that is integral m dx plus n dy along this curve, that is OA, plus integral m dx plus n dy along this line, that is AO, in this direction. So in single integral we are converting these total values either in terms of x or in terms of y. So along this direction OA, y equal to x square, and along this direction AO, y equal to x. So that means in case of this direction OA, put y equal to x square. If you are substituting y equal to x square, so then dy equal to, what is dy? 2x dx, and the limits of x is varying from 0 to 1. So therefore put y equal to x square, dy equal to 2x dx, and x limits are 0 to 1. So substituting this, x into y value x square, x into x square plus y square, that means x square whole square dx, plus in this x square dy is 2x dx, and x is varying from 0 to 1. So x into x square, that is x cube plus x raised to 4 plus 2x into x square, that is 2x cube dx. Here 2x cube, this is x cube, that is 3x cube plus x raised to 4 dx, and x is varying from 0 to 1. So now in this, along the direction of AO, y equal to x. Then dy is, if y equal to x, dy equal to dx, and x limits are, in this case x is varying from 1 to 0. So therefore x limits are 1 to 0, and y equal to x and dy equal to dx. So therefore in this, substitute along the direction AO, x into y value x into x plus x square dx plus x square into dy. So dy value is dx. So this is x square plus x square plus x square. So that is 3x square dx, and limits of x is 1 to 0. So now integral 0 to 1 3x cube plus x raised to 4 dx plus integral 1 to 0 3x square dx. So therefore substitute in this, integrate this 3 into x cube integral x raised to 4 by 4 plus x raised to 4 x raised to 5 by 5 between the limits 0 to 1. So substituting, so 3 by 4 into 1 minus 0, that is 3 by 4 plus, for this 1 by 5 into 1 minus 0, that is 1 by 5 only. For the lower limit, if you are substituting lower limit 0, so 0, so this value is 0, this value is 0. For the lower limit, this total term is 0. So 3 by 4 plus 1 by 5. So LCM is 20. So 15 plus 4, 19 by 20. Now cancel this. X cube. So put x equal to 0. So 0 minus 1 cube, that is 1. So 0 minus 1. So take LCM here. So that is 20. So 19 minus 20, that is minus 1 by 20. So therefore integral m dx plus n dy over the curve C equal to minus 1 by 20. Already we are calculated this double integral of dou n by dou x minus dou m by dou y dx dy over the region R. So that is minus 1 by 20. So therefore these two values are equal, means theorem is verified. So thank you for watching. Please subscribe.